Hello, my name is Heather Ringstaff, and today I'm going to be proving that given triangle ABC, the greater side lies opposite the greater angle, and the greater angle lies opposite the greater side. So we're going to prove that side AB is greater than side BC if and only if angle C is greater than angle A. We're given triangle ABC, and we're going to have two cases. First case is we're going to assume that side AB is greater than side BC. Well, by congruence axiom 1, we know there exists a point, and we'll call it point P, on ray CP such that side BC is congruent to side BP. So there's a ray that emanates from point C here. And therefore BC is congruent to BP. Well, by definition of an isosceles triangle, we have that triangle CBP is isosceles. And just to make it easier to reference the different angles, I'm going to let angle 1 be equal to angle BCP. I'm going to let angle 2 be equal to angle BPC, and angle 3 be equal to angle PCA. Since, as stated before, we said that triangle CBP is isosceles, and by Prop 310, we know that angle 1 is congruent to angle 2, because the base angles of isosceles triangles are congruent. And also, given that ray CP is between ray CB and ray CA, we can use angle addition and state that angle 1 plus angle 3, which I forgot to mark in my diagram, is equal to angle BCA. And again, that is by angle addition or Prop 319. Angle 2 is an exterior angle to triangle CPA, and by theorem 4.2, we know that angle 2 is going to be greater than angle A, because any exterior angle is going to be greater than the remote interiors. Well, we know that angle BCA is greater than angle 1, and angle BCA is also greater than angle 2. That's by substitution. And therefore, when we use the transitive property, this means that angle BCA must be greater than angle A. And that's by the transitive property, which is what we were trying to prove. So that brings us to case 2. All right, case 2, we're going to have three subcases. We're going to assume that angle C is greater than angle A. So for case 2, we're going to say that AB is less than BC. Well, this implies that angle C is less than angle A, which contradicts our hypothesis. And likewise, case 2b, if AB is equal to BC, this implies that angle A, or angle C, whichever one you want to start with, angle C is congruent to angle A, which also contradicts our hypothesis, which leaves us with only one possibility, and that is that AB is greater than BC. And therefore, if angle C is greater than angle A, then side AB has got to be greater than BC. So using case 1 and case 2, we've proven in both directions that if side AB is greater than BC, angle C is going to be greater than angle A, and if angle C is greater than angle A, then side BC is going to be greater than BC.